The aim of our study was to test the effect of transformed visual cues on wrist orientation using immersive virtual reality to explore how visual information constrain the way we actively estimate our movements in light of an active inference framework where actions are seen as ways to minimize the difference between proprioceptive predictions and current sensory informations. For this experiment, we developed a bespoke virtual reality environment where participants had to turn the dial as far as they felt they comfortably could by using the controller held in their right hand. We randomly assigned 3 different conditions, 10 trials per condition, in a total of 30 trials. In condition 1, participants saw the virtual dial 20% less rotated than the controller in the physical world. In condition 2, participants saw the virtual dial as rotated as the controller in the physical world. And in condition 3, participants saw the virtual dial 20% more rotated than the controller in the physical world. We also randomly assigned whether participants could see solely the controller or the controller and a virtual hand. In terms of outcomes, we collected the controller z-axis rotation angle during and at the end of each trial. We also collected the sense of embodiment of the virtual hand through a questionnaire at the end of the experiment. In terms of the results of our study, we did not find any significant differences between transformed and untransformed visual cues of wrist rotation, both in terms of end of trial rotation angle and maximum controller rotation angle achieved by the participants. We did find quite a marked variance between collected rotation angles, which may have affected our findings. Although not part of our main outcome, we did find that participants who saw the dial rotated 20% more than the physical controller rotated their controller faster when compared to the condition where both the virtual dial and the physical controller were aligned with differences of 20 to 30 degrees per second. We did not find that manipulating visual information alone was enough to constrain active wrist movement. However, we did find that rotation speed seems to be affected by manipulating visual information. This only happened in one of the conditions and so requires further investigation. We also found wide variance within the conditions in terms of rotation angle and rotation speed, and so are in the process of completing more complex statistical analysis. Thank you.